So, Richie, what is the secret sauce? Or I guess it's not so secret because you have blogged about it. What is the not so secret sauce behind polars being so much faster and more memory efficient relative to the incumbents out there?
For relational data processing, DataFrame like data processing, there are a few things you can do. It's actually pretty old, relational data processing. It's what databases do for over decades. Um, and it's what SQLite does, and it's what ClickHouse does, and Snowflake. So all these databases they exist and they have different performances. Um, and the different performances are because of various reasons. For instance, if you look at a SQLite, uh, which is row oriented, which is great for transactional processing. Transactional data processing is when you load data, when you have a database and you use it when you do transactions. For instance, if you buy a product, you update that row, and then you need to check if that transaction was succeeded or not. Otherwise, you have to fall back. That's an application of databases. Another one is analytical data processing, and that's more where polars, pandas, or Snowflake come in. And in that case, doing things columnar is way faster. So columnar means that you process data column by column. This is something pandas does as well. They're based on NumPy, but there are other things you need to do, which pandas has ignored, and that's multiprocessing or multi-threading, to be just multi-threaded parallel programming. I mean, my laptop has 16 cores available. I want to use them. It's a waste of those resources if you only use one core for expensive operations like joins or group bys. The other one is that Polars is close to the metal. Pandas is just taken NumPy, which was meant for numerical data analysis. It's great, but when you had string data before NumPy 2.0, there was no real good solution for that. And if you talk about nested data like lists and structs and arbitrary nested data, pandas actually sort of gave up because it just used the Python object type, which means, hey, we don't know what to do with this. We let the Python interpreter see what to do with this. And in that sense, polars. So pandas took NumPy and built on top of that, but it was never really meant to. NumPy was never really meant to build a data processing tool like a database on top of that. And polars is written from scratch. It's written from scratch in Rust, and every performance critical data structure we control, um, and by that control we can have very effective cache hierarchy, very effective caching behavior, very effective resource allocation, very effective control over memory. That's the most important part, because a lot of compute or a lot of resource is in control over memory. And then the third one I think is very important is that we also use an optimizer. So we actually made a different. If you look at databases, they can be really fast because of performance and how you write the code, how you write the kernels that execute the compute. But there's also an optimizer, and this optimizer will make sure you only do the compute that's needed. And this is very similar to what a C compiler does. If you write your C, you can be sure that the computer will never execute the code as you've written it. There will be a compiler in between that will try as hard as possible to prove that it doesn't have to do certain kinds of work. And that's actually quite similar to data processing. If you don't need to load a column, this saves a whole IO trip. This saves a whole resource allocation. So this can save, yeah, a huge amount of work.